officially start dosage calculations, okay? On your dosage calculation sheet, there are a couple of formulas I have in there, okay? We have Young's rule, Fried's rule, Clark's rule. Those are the three most common ones, but we don't use them very much. If you watch the video lecture, I had tips on how to remember them. Young's rule, Fried's rule, and Clark's rule. Let's start off with Clark's rule. What did I say in the video lecture? How do I remember Clark's rule? Clark's is a shoe brand, right? And all of our weight are on our shoes. So the calculation is based on weight. Nate, looking at your cheat sheet, formula sheet, what's the formula for Clark's rule? This is a calculation, pediatric dosing, based on a child's weight.
Where on the sheet is it?
It should say dosage calculation.
I might have the wrong sheet pulled up. No, on the math handout, right?
Yeah, it's the second sheet that I added in your first week, day one, Wednesday. It's in there. I told you you can print those two formula sheets. Anyone who can help? Clark's rule formula. Put it in the chat box. Clark's rule. Calculation based on a child's weight. Clark's is a shoe brand, so all of the weight is on our shoes. Just put it in a chat box. It's weight in pounds divided by 150 times the adult dose. Did you find that? You should see that on your first week handouts, okay? That's calculation based on weight. However, now we don't just use calculation based on weight anymore, okay? Especially not based on what? Just height alone or just age alone. If you noticed, which I'm going to get right now because my son has it, Tylenol and ibuprofen. I'll be right back. I have here, my son has toothache, okay? Not toothache, but gum ache because his first molar's coming out, okay? So I have here children's ibuprofen, okay? And I'm talking about pediatric dosing right now, okay? In the past, we can use calculation of the dose of the child based on age, okay? But through time, it's not accurate anymore because some kids of a certain age tend to be heavier or skinnier. My son is on the skinny side, okay? But some kids tend to be on the heavier side. So we can't just base calculation on age. We still use calculation based on weight right now, okay? This is why I'm asking you, what's the old way of calculating a child's dose based on weight? We call it a Clark's rule, which Don put on the chat box. In the chat box, weight in pounds over 150 times the adult dose. The 150 is based on an average adult weight, 150 pounds, okay? It's always proportionate to an adult dose. It's not very accurate because it's just body weight. However, that formula we can still use, a child's dose, we can still use for animals, okay? For animals. Dosage calculation in the vet. Why? It's hard to measure the height of an animal. Do we measure it with 4 legs down or legs stretched out, right? So it can't be a height and a weight combination. So weight is still useful. The other two calculations are based on age, the Young's rule and the Fried's rule. And in my video lecture, I told you how I remember it. The Fried's rule, we do not give fried food, supposedly, for kids younger than 2 years of age, which means the calculation is based on kids age 2 and younger. Don, would you write the formula for Fried's rule in the chat box, please? Thank you. So this calculation is based on, you can use this if you are calculating based on age, 2 years and younger. And the formula for Fried's rule is age in months over 150 times the adult dose. That's the Fried's rule. You have that in your handout. And then we have another calculation, which is the Young's rule. Young, calculation based on age, 2 years and up. 2 years and up, okay? Dawn, can you put the formula for Young's rule in the chat room? Age in years over age plus 12 times the adult dose. So this time the age is in years. So the Fried and the Young's is based on age. The Clark's is based on weight. Not very accurate anymore. With the increasing obesity problem of kids in America, we'll have to have it more accurate. Cannot be based on age anymore. So what did manufacturers do? They came up with this table, okay? The table is a combination of weight and age, okay? It says in here weight in pounds over age in years, and then the dose. I'm using ibuprofen, a generic ibuprofen, Kroger ibuprofen, children's ibuprofen, okay? With the dose, 100 milligrams per ml. Pain reliever, fever reducer, it's an NSAID. Lasts up to 8 hours because ibuprofen is for lasts 6 to 8 hours. On the side, there'll be a table right here, okay? And it says in here, under 24 pounds, under 2 years of age, ask a doctor. 24 to 35 pounds, 2 to 3 years of age, 5 ml. 36 to 47 pounds, 4 to 5 years of age, 7.5. 48 to 59 pounds, 6 to 8 years old, 10 ml, okay? 60 to 71 pounds, 9 to 10 years, 12.5 ml. 72 to 95 pounds, 11 years, 15 ml. However, my son is 9, so I should go to the 9 to 10 years old, but he's not 60 to 71 pounds. You see how it can't be just age and it can't be just weight. It has to be a combination. So my son falls more on the 6 to 8 years old because he's on the skinny side, 48 to 59 pounds. So instead of giving him 12.5 ml, I'd give him 10 ml, which is the 6 to 8 years old, 48 to 59 pounds. You follow? That's what I'm saying as to it's not accurate anymore. There's a more accurate calculation, which I'd like to show you. It's on the board. It should be on the board. Calculation based on body surface area. Can you see my screen? Okay. Body surface area is a combination of height and weight, okay? Or we can use the chart, okay? It's in your book. It's in your textbook. But for math purposes, for calculation purposes, this is the computation for body surface area. And body surface area will be meter square in unit, lowercase m and a superscript 2. You follow? So it's going to be lowercase m and a superscript 2. Can you still see my screen? So this one should be m superscript 2. Is that clear? There are 2 formulas you can use for body surface area. Okay. One would be in metric. You can use either. Okay. Height in centimeters, because it's metric, times weight in kilograms, because it's metric, divided by 3,600. But do not forget that the square root for this one is your metric measurement. The square root covers everything, which means you have to get the square root of your height in centimeters times weight divided by 3,600. I don't know if it's easier to remember the 3,600 or it's easier to remember the 3,100. But note, if you're trying to remember the 3,600, that would be your metric system. Is that clear? If you're trying to remember the 3,100, it's easier for you to remember the 3,100. That will be your household, which means you're going to have to use the inches and the pounds divided by 3131. And always remember, we still follow the PEMDAS rule, no matter what. Parentheses and exponents first before multiplication and division, followed by addition and or subtraction. Is that clear? Also, just like you have to remember that normal saline will always be 0.9% sodium chloride, you have to remember that a normal body surface area of an adult is 1.7 meters squared. Some books will say 1.71. Some books will say 1.73 meters square, okay? This is necessary because sometimes it's a ratio and proportion question. You're gonna have to figure out the dose of a child with only one variable given. And that is when you use the 1.7, okay?